Hi, so this is our summary for our Thursday meeting. Hopefully, moving on, we'll start having short videos regarding homework questions or important questions that we are received during our Thursday meeting. Let's start by uh, solving question 5.2. So part A is straightforward. It asks to write the time domain integral equation that arises from applying KVL. So we can say that, as we know, right, I think mean, I don't have mouse control. I don't have. Let's start by saying that. Can start writing here. V, VS, V source. All right, we are working the time domain. So V source equals V resistor plus V capacitor. We have, I think, so in that V source is equal to 2 over S plus 1 in the S domain. Using inverse Laplace transform will be equals to e to the power negative alpha t. Alpha is negative 1, so e to the power negative t, u of t, 2, 2 times this, equals V resistor, which is 5 times I of t plus V capacitor. Remember the equation for the V across a capacitor is equals to 1 over C integral of the current in that capacitor plus the initial condition V0, uh, V0 negative, which is 4.5 volt. 4.5. You can probably clean this function out or rearrange it. We mentioned that we can solve for IFT, but it just asks to write the time domain integral equation that arises from applying KVL. So this is part A. Part B, right, it's more fun, and there are some points to clarify from our discussion. So it asks for, by first solving for I of S, determine the time domain current I of t. So, all right, let's start. Similarly, in the S domain, V source S equals V capacitor S plus V resistor S. We can solve for the circuit in using this form by like substituting VS. We already have VS and VC and VR, but I found that another way to solve it mathematically, which is slightly easier, to just directly start from I of S, since that's what we want to solve for in the end. We know that I of S equals IC of S equals I R of S. So let's solve for IC of S, since it's the most complex, and let's substitute all the unknowns from the function on the top. So you know that IC of S, the current across any capacitor, equals C times CS VC. CS VC of S. We can drive this. Like if you're not sure about this, we know that ZC, the impedance in the capacitor, equals 1 over SC. So, and we know that ZC equals VC over IC. So solving from IC, you'll get this. So currently, we do not have VC of S. But from the equation on the top here, we know that VC of S equal VS minus VR. So VCS equals VS minus VR. I mean, it might seem that we are taking the long route, but it's just, it will be mathematically easier or clearer in the end. Like anyway, should give you the same answer. All right, so we have VS and we have VR, so let's substitute for them. We know that, or let's first, we know that VR equals I times 5. So, and VS is given in the top. All right, let's continue in the function of IC. ICS equals CS times VC, which is VS minus 5 IS. And we know that there is an initial condition, so minus VC0. So solving for I of C. All right, so let's take all the i's on one side. Let's get this I 5is, negative 5is. So this is actually C times S times 5is. Let's take it to the other side. So this new circuit will become IC of S times 1 plus CS times 5. Yeah, that's the way. So plus CS times 5 equals C times S V source in the S domain minus V capacitor initial condition. All right, I think we can start substituting now. So this, like, this way, just substitution becomes easier. You don't need a calculator or anything to solve. Right. So we know that capacitance is 200 milli, that's 0.2, and resistance is 5, Vs2 over S plus 1. So capacitance is 0.2. So 0.2 times 5, that's 1. I C S, oh, yeah, times 1 plus S equals 1 plus 5 over S equals C S, and Vs was 2, 1 plus S minus 4.5. All right, we are solving again for C of S. Uh, let's, so I C of S equals, let's take this to the side, equals 2CS over 1 plus S, 1 plus S times 1 plus S minus 4.5 over 1 plus S. Let's multiply this part times C here. Times C times C. Let's multiply this part by 1 plus S, top and bottom, to enable us to take it under the same the numerator. So 2cs over 1 plus s squared minus 4.5c times 1 plus s right, equal ICS. So this part will be equals to 2cs minus 4.5. C was 0, or we can substitute later. So minus 0.5c plus, minus minus mi minus 4.5c s over 1 plus s squared. So 2cs, like this and this can be, let's substitute for a c first. 2 times 0.2 is 0.4s minus 4.5 times 0.2, uh, so 4.5 times 2, that so 0.9 minus 4.5 times 0.2, that's 0.9 s, so that's 0.4 minus 0.9 s, 1 plus s squared, that's negative 0.5, negative 0.5 s minus 0.9 over 1 plus s squared. There are a bunch of ways to solve this function, but I think for me the easiest way is to cross the s squared, since, or to make the power of the numerator, or to move s from the numerator by taking this numerator, taking the top part in new m, equal negative 0.5 s minus 0.9. First, take 0.5 outside, equal negative 0.5 s plus 0.9 over 0.5 over 0.5, which is 1.8. Equals negative 0.5 s plus 1.8. Uh, so we want to have s plus 1 on the top. So equals negative 0.5 s plus 1 plus 0.8. So times plus plus 0.8 times negative 0.5, which is minus 0.4. So I of s equals 0.5 s plus 1 over negative 0.4 over s plus 1 squared. So equals 0.5 over s plus 1 minus 0.4 over s plus 1 squared. Let's check our table for inverse Laplace transform. Checking the table. So it will be equals, this part is 0.5 e to the power of negative t minus 0.4 t e to the power of negative t.